Just for the record, almost every video that ever gets released on YouTube is always previewed first, almost always previewed first to our Patreon subscribers. They get first crack, they get the first breaking news, and then we, after 3 days, we then put it up on YouTube, so that our Patreon subs are way ahead of the gang. The What's happening in the magnetosphere is extraordinary. Stuff like this happens from time to time, but I mean, come on, when's the last time you've seen a magnetosphere that looked like this? And what's weird is the open field lines that are normally black are red, which indicates a closed field, but yet the closed field looping is black still. Generally that turns red too, because the lines cross and the machine or the satellite picks up the magnetic field as a closed field and not an open, streaming, moving magnetic field. This is the solar wind. Look how fast it got. I never thought that wind would get this fast on this side of the sun. But that coronal hole that hit us was from a very small but round coronal hole that was equatorial. So when you have a small opening, a lot of times the particles that come out of that opening and through that opening are faster than through a wider opening. Kind of the same thing when you close down a blower, you put a tighter nozzle on your blower, you blow faster air. Just like when you turn on your vacuum and you put on that little long nozzle, that sucks faster than the big hose all by itself, if you know what I mean. So the smaller confined area that you run water or air through or particles through, the faster they will run. So that coronal hole was pretty tight, but it shouldn't have lasted for over a week. There's something going on, and it's direct opposition, almost direct opposition from a brown dwarf that we are going to pass in between the sun, probably within a week or two, and the earthquakes will tell us. And we've already told you what to expect on earthquakes. I wanted to see what the magnetic field standoff position looked like. This measures how far the magnetic field is from Earth. It's hovering around 10 to 12. I mean, it used to be up around 13 or 14 Earth radii, but it's been compressed for years now. People want to call it a collapse. It's not a collapse. But what got me is when I went back a few more days, there was a lot of missing data, very periodic, on this magnetosphere standoff position. I have never seen the data broken up like that. So I went to other instruments just to see if they were picking up data. We saw a big gap in some of the magnetosphere data, but all of the GOES satellites, I mean, these are 3 different satellites, were doing the same anomaly. They were like shutting off, then shutting back on, and shutting off, and shutting back on, similar to all the other satellites. ACE did not do this, the ACE satellite. But what was happening is that we're getting wind from the opposite direction, consisting of neutral helium, which doesn't show up on an energy measurement hardly at all, but the electrons do. And this magnetic field simulation gives you concentration of particles, not so much the energy. But there was a lot of bizarre things going on magnetically in our magnetic field. Some stuff I have never seen before. And so we're showing you today. Here you see a backside encroachment. It's actually pushing in from the left to the right. Well, the sun's off to the right, so you can see this like eyeball shape, and you can see that as those concentrations get bigger on the back, it affects what's going on in the front. And without any particles coming in from the right, where are all these coming in from the left? You know, usually you can see the wraparounds. And there is some wrapping around, but almost in the wrong direction. And so those do eject out to the left, usually, until something very strange happens. Let's see if I can get this to show you. But we had a huge concentration of backside particles. We even had rings on the backside. The electron simulations show that these disturbances And look at the front side. We have an outer shell, an outer bow compression zone that's lighting up yellow. And it's lighting up yellow because it's getting electrons. It's actually absorbing some electrons coming from a different direction. That is why the magnetosphere hasn't completely collapsed or compressed with all of this activity going on. Electrons do not compress your magnetosphere. And then what happens? Watch this progression. You see all the energy and all these particles coming in and filling in from the back side. And when they're actually encroaching. You can see those little fingerlings wrapping around towards the front. They're working their way around. Notice as the backside presence swells, so does the magnetosphere. It tries to push away. And as those fingers come around, watch what happens. This is amazing. As those fingers come around, when they finally connect and make a connection, in a single instant, this is what happened. Poof. There went all the electrons. And where did they go? They went out in all directions. And some went out into the bow compression zones to the right-hand side of the simulation. Meanwhile, look at the inside, the interior of Earth. Look, there, the inner rings, the geosynchronous orbit of the satellites. Notice there's nothing going on. All of a sudden, it's this dark blue. And you can see some deformities in that outer ring, but my goodness, all those particles just disappeared the minute those front little fingers touched and made a connection. And then with all the electrons gone, the only thing left was the helium wind, which carries almost no energy. And look at it. It's compressing the magnetosphere. That magnetosphere, with almost nothing going on in the picture, shows a compression almost down to geosynchronous orbit. That's what happens when all your electrons get energized by a connection, and they just expand out, kaboom, and explode outwards in all directions. That one did, not just a tail stream. Here are some bizarre shapes to our magnetosphere. This is what's been going on all week. We get a compression, then an expansion, and not just any expansion, bizarre expansions. And sometimes the expansion is so big that the instrument can't even pick up the boundaries of our magnetic field. They extend past the frame of the simulation. That's amazing. And the disturbances of the magnetic field lines, the undulations, the lack of uniformity and symmetry shows that we're undergoing a lot of fluxing, a lot of electron pulses coming in and being ejected out, coming in and being ejected out. Now, these instruments that I'm showing you currently, I consider them suspect because these used to show saturations. And when they don't show saturation, but then you go to something like this that measures one of the shells, our electron shells, shows almost a complete saturation. The two instruments aren't agreeing with respect to concentrations. I don't know why. It could be that they're measuring two different portions of our magnetosphere. It could be that we just aren't looking at the right energies on one simulation. But the fact of the matter is, that's a lot of electrons in a shell. And much of the electrons do not come from the sun. Some of them do, some of them don't. But when a coronal hole stream hits and you have a widespread plotting of speeds, temperature, and densities, usually that's not just a coronal hole stream, because I showed you all the scientific articles showing that all of those parameters are equal. There's equal electrons to protons. They have the equal temperature. They don't travel at the same speed, protons versus electrons, but all the electrons basically are traveling at the same speed as one another. All the protons are traveling roughly at the same speed as one another. The helium-3 and the helium-4 coming off the coronal hole streams all travel at a very set, confined parameter. So, and what we're seeing is some of the instruments are picking up differences, changes in that wind, changes in speed, density, and temperature that don't conform to stuff coming off the sun. So that's the second brown dwarf. I wish we could see it. All the energy is heating the ocean, and just because your oceans are heating and just because you're breaking heat records doesn't mean you don't have ice still on your ice cap. We're losing it, but it's still there. It's still air conditioning there. And when air goes up to the North Pole and gets drawn back down, we're going to get snow. Sometimes in freaky places, sometimes early, sometimes a ton of it. But one thing always common to all the snow that we're getting now, it sure melts pretty quickly. We had a hailstorm the other day that just covered the ground with hail, like I've never seen it. I've seen pictures of this kind of hailstorm, but it looked like snow. And then the drifted hail all solidified together like a giant rock, kind of like when you take crushed ice and you pour salt over it and it becomes like one solid ball. The hail remained in drifts for 3 days. It has to be because of the aluminum oxides that are in that hail. And next time it happens, we're going to test the hail. We're going to test it. We may not report what we find for our own safety, but we're going to test it for our own knowledge, because it's just weird to see a drift of hail become a solid drift of ice. It's just kind of weird. But Lorenzo, yes, setting records. Lorenzo is the furthest north, latest in the season hurricane. And the reason it's breaking records is because the ocean is at record warm temperatures. Therefore, you're going to see more hurricanes, stronger hurricanes. Remember a few years ago, we had like 4 or 5 hurricanes in the Pacific all at one time? It was craziness. Hurricane Lorenzo broke records. And, we talk about unprecedented stuff. We talk about unprecedented wind speeds, unprecedented hurricane size, unprecedented number of hurricanes. But this one is unprecedented too. It's so far north, it should be over cold water, and it should have, fallen apart long before it did. And it's kicking butt in Ireland right now. So be thinking about Ireland. Krakatoa, that island blew up, and it was actually a flank collapse similar to Mount St. Helens. 400 people died, several thousand injured, and many more displaced. And it really sits in a very bad place. Sumatra has already been pummeled by earthquakes and tsunamis. Didn't need another tsunami, but they got one, as did Java. And all of these places suffered casualties, significant loss of structure and life. There were precursor warnings before the explosion. I'm reading this seismogram. There's things on this seismogram that just do not make sense to me. And the volcano explosion doesn't show up as any change. So it makes me suspect, where the seismogram came from. But the article did talk about how there was warnings, and almost all volcanic eruptions have warnings. It's whether or not we listen and heed those warnings or not. And finally, an article in the UK press talking about the loss of fauna and wildlife. And they're talking about how 1/4 of the mammals may face extinction. And they didn't give really clear timetables, but the message is loud and clear. And they'll probably try to blame it on carbon dioxide. So what all of this means is that we're going through a lot of unprecedented stuff. We're in very uncertain times. And they're revealing bits and pieces of the truth to us a little bit at a time. And it's all conforming to stuff that we've told you 2, 3, 4 years ago. So the bottom line is nothing can replace the fact of you being self-sufficient. The more people that are self-sufficient, that can get through some rough times, the more people that are in that kind of situation, preparedness, then the better off all of us will be. So it's really irresponsible for your neighbor not to be preparing and not to be at least, planning for the unexpected. And, you don't have to talk about the brown dwarf. You could just talk about the mega death of fauna. Billions and billions of animals, fish and birds mainly, but heck, thousands and thousands and thousands of caribou have died. There's a long list of mammals that have gone, especially sea mammals. So with the Fukushima still melting down, with who knows what the political situation is, with crazy weather, incredible sudden storms, one extreme to the other, snow to heat, and back to snow and back to heat. I mean, there's so many things that can disrupt your food supply, your power supply, and your communications. So you got to be able to be just prepared for that. It doesn't mean you have to have 3 years supply of food, but man, having a little bit can go a long, long way. And frankly, I buy refried beans in big cans when it's on sale. That stuff keeps forever. Some of it has lard in it, so there's plenty of calories, and the beans are actually vegetable protein. So it doesn't mean I'm crazy. It means that I like to feel secure. It means that I like to feel good about the future. I like to feel that I'm better off than most people and better informed than most people. And that in itself is reassuring to me. So it should be reassuring to you. So get prepared. Just stay on your alert. Nobody's saying the Earth's going to flip over. Nobody's saying we're going to have a super eruption. In fact, if we thought that was going to happen, we would be the first on the YouTube and on Patreon to be shouting it out. So, but getting prepared and having a good supply of food and water, and a plan is priceless. And people affected by power outages, people affected by floods, there are many people who got caught unprepared. And those people ended up standing in lines for hours to get water. Those people ended up getting rescued from their homes. I mean, don't be one of those people.